Okay, we're up and running. I guess I'll get to sharing right away here, and then I want to make an announcement. So hopefully all of you should be seeing the Chapter 2 review now. So I want to make an announcement. Jane asked me after class yesterday if the review was posted, and I said I thought it was. Well, I looked, and I did not have, I had notes for every section, but not for the review. So I've now since put it up there. So if you go on the website, go to the very bottom of Chapter 2, you'll see 2.1 all the way through 2.8. There are notes, and then there's Chapter 2 review notes. And in addition to that, I went beyond what I said I was going to do. I decided that that old test that we were looking at last time, I have decided to include that. So that's in there. And we can certainly use that today. And I might need a reminder from you guys as to how far we got. So welcome, Brandon. Welcome, Mason. Glad to have you on board. I'm going to be pretty reliant on questions today, guys. First, I wanted to show you a few slides that we didn't have yesterday, and things that you really need to know. First of all, this is what? Business stuff that we're assuming everybody, you need to know this as background. I know you know this top thing up here, that profit equals revenue minus cost. So if in a problem they give you the revenue equation, they give you the cost equation, and they ask you to find, let's say, something about the profit, you've got to realize that you first have to calculate the profit by subtracting the cost from the revenue. And then, let's see, this isn't totally clear here, but when this is a lowercase p, capital P, that stands for profit. When you get a lowercase p, that stands for demand. And this equation students often forget. If I give you the demand and how many units were sold, X, then you calculate the revenue by taking the number of units times the demand. That's that R equals XP equation. So you need to know that in some of those business problems. And then over here on the right, some terminology. Whenever you guys see the word marginal, remember, so if I ask you for the marginal cost, I'm saying find the derivative of the cost. If I ask you for the marginal revenue, you find the derivative of the revenue. If I ask you for the marginal profit, then you need to take the derivative of the profit. So marginal, that word, right away cues you that you need to find the first derivative of whatever I've asked you. So just a reminder, it's been a while since we've talked about that, and that's part of Chapter 2. Then I also have a slide on just a reminder that when you do multiple derivatives, I don't know, this may or may not come up, but if it relates to physics or motion, then these are what? The regular function, that's just the height or the distance. When you take the first derivative, then you're on velocity. Second derivative, acceleration. Those are the ones you really need to know. I doubt if I would bring up the bottom one there. So I'll just put a dividing section there, but the third derivative sometimes is called a jerk. Whiplash, another way to look at it. So I wanted to, first of all, just take a few moments to look at those. And now I think what I'll do is I'm going to go back to that, that old test. I must admit I don't remember exactly where we were in that old test, so you may have to help remind me, okay? I'm pretty sure we talked about these first three problems already. Now I think we were talking about number 5, weren't we? Maybe. I think number 5 is where we ended up. So let's just discuss this, and then maybe and let me know if I'm wrong. I think we talked about everything up through there. So on number 5, we're given that the temperature T has this equation based on time for how long food is how the temperature drops the longer food is in a freezer. So freezer, if it's in for 1 hour, that'll lower the temperature this far. If it's in for 2 hours, anyway, this is the equation for calculating what the temperature will be in Fahrenheit after T hours. Part A says, find the formula for the instantaneous rate of change in the temperature. So there's those key words again. Instantaneous rate of change, that's just another, that's code for I need to find the derivative of the temperature. And then we'll do that in just a second, but part B says, what are the rates of change of the temperature when T equals 1, T equals 3, T equals 5, and T equals 10? Well, B is easy, right? Because once you have the general derivative, which you'll have in part A, then B is just a matter of substituting in those 4 different values for T. So I'm going to jump to, hopefully, I think this is, yeah. So here's the same thing, only with some of my solution work being done here. Okay, so in part A, we're trying to find the formula for the instantaneous rate of change of the temperature. So what's a derivative? Well, we got the quotient rule, right? Because it's a division. You know, here's the, oh, I got a strange, hang on a second. Here's the problem that we're dealing with, and we need the quotient rule. So when I started working right here, I said, all right, denominator times derivative of numerator. Well, the derivative of the numerator is 0. So I didn't even write that. So really, there's a big 0 out here. Denominator times derivative of numerator. Well, times 0, so it's gone. Minus the numerator, 1300, times the derivative of the denominator, which is 2t plus 2. All over denominator squared. Okay, so that's just a quotient rule. So really, I don't know, there's really not a whole, I mean, there's no need to really multiply that out. Now it's just a matter in part B of plugging in, all right, what's the first derivative at 1? And that's, you know, and we don't have to go through it, but I just literally stuck in a 1. 2 times 1 is 2, plus 2 is 4. And 4 times negative 1300 is negative 5200. And on the bottom, what do we have here? 1 squared is 1, plus 2 times, so that's 3, and 3 plus 25 is 28, and 28 squared is 784. And then to simplify it and you know, get your answer. So there's t prime at 1. I mean, this is just arithmetic. You can look at, so each time, of course, we're going to get a different rate of change of the temperature. It's kind of interesting. After what hour is the greatest? Where is, of those 4 hours they gave us, 1, 3, 5, and 10, which one has the greatest rate of change of the temperature? It turns out it's in the beginning. That makes sense, right? If you stick something warm in a freezer, it's going to have a more dramatic drop in temperature at the beginning. And then as the object gets more and more frozen, it's going to go down, but by less each hour after that. And eventually, it should just be whatever the temperature of the freezer is, right? By the way, the reason these numbers are negative, -6 point, because the temperature is going down. Okay, send me any questions. That's basically number 5. Okay. As we go on in the test, I don't remember if we talked about this or not, but number 6 on this particular test was a 10-pointer. Got that? So on this particular test, there's a lot invested in this problem. Of course, I'm asking you to do 4 different things here, A, B, C, D. So let's get going here. A rock is dropped from the tower on the Brooklyn Bridge. The bridge is 276 feet above the East River. I think we talked about this too, didn't we? Anyway, here's the equation. Please note that negative sign should be in there. S equals -16t squared plus 276. All right, let's talk about A. Find the average velocity. That's the same as saying the average rate of change. Average rate of change. Very important words. Means what? Just find the slope. The slope after the second, at 0 and at 2 seconds. So you notice the very first thing I did up here is said, well, let's find the height at 0. And that's easy. Just plug in a 0 into the equation. -16t squared is 0 when t is 0. So we just get 276. When you plug in a 2, it works out to 212. So there's our 2 points, which I wrote over here. Do the slope. And the average rate of change, I mean, just a little bit of arithmetic, is -32 feet per second. So on the average, that's how much the rock is dropping each second. Average rate of change. As opposed to part B, find the instantaneous velocity. Sorry. Find the instantaneous velocity when t equals 2 and t equals 3. Well, if we're going to do an instantaneous velocity, we need to find the derivative. So go back to the original function again. Easy derivative, right? Power rule, -32t. So you had to realize you got to find the okay, now we've got the general derivative. Now, what's s prime at 2? Yeah, that's easy. Just plug it into the -32t formula and you get -64 feet per second. And what's s prime at 3? Again, just substitute it in. -96 feet per second. Part C. How long will it take for the rock to hit the water? This is totally an algebra problem. It has nothing to do with calculus. Well, obviously it agrees with calculus, but it's really algebra. When is the height, this equation they gave us in the beginning, equal to a height of 0? And, I just subtracted 276 from both sides, and then I divided both sides by -16, and then, you can take the square roots. According to this, I think if you do all that calculating there, it comes out to a little over 4 seconds. Okay, so whatever that number is, and by the way, here's the exact way to write that. Just over 4 seconds is the square root of 69 over 2. So that's why you'll see in the next line it says, when the rock hits the water, how fast is it going? So I need the velocity, which is the first derivative, and I need it at the point of impact, which we just figured out in part C, square root of 69 over 2. So that's why we're looking for S prime at square root of 69 over 2. Well, S prime, here's the formula right up here. So all I got to do is plug in square root of 69 over 2. And I didn't write the label down. I should have. So what's its speed when it hits the water? Negative 132 feet per second. So now there's a lot going on there. 4 different questions. Please let me know if you want to ask anything about those. So there's kind of a classic example of a gravity problem where you've got to know that velocity is the derivative of distance. And had I asked you, I didn't ask you, but if I'd have asked you about the acceleration, you need to know that then we would have had to pull out the second derivative. You know, this thing of when will this thing hit the ground or hit the water, that's really an algebra problem, setting the height equal to 0 and using your algebra skills. In this case, I didn't have to complete the square because I didn't have a bare t. So this one was, you know, I took it easy on you. I gave you a pretty simple height problem on that one. If there was an extra t in there, you would have either had to factor or use the quadratic or complete the square. Again, all algebra things. All right, not seeing any questions, so I'm going to take a look at number 7 on that previous test. Find the equation of the tangent line to the graph of this function at x equals -1. So this is, again, we've done this over and over. Instead of just finding the derivative, which we have to do, right? What's, hang on just a second, I got to think here. Yeah, what will the derivative tell us? The slope of any tangent line. So we got to start with that, find the derivative, and then once we've got the slope, then we can use this clue on the end here to find the y-intercept. So, step 1. Find the derivative. Okay, so what's the derivative of x cubed? 3x squared. What's the derivative of -5? Nothing. What's the derivative of, really, isn't this right here, what I wrote up above here, isn't that just another name for 3x to the -3 power? So what's the derivative of 3x to the -3? Power rule, -3 times 3 is -9. X, reduce the power by 1, becomes -4. Okay, this is another, I mean, that's fine, or here's another way to write it. It doesn't really matter which you use, this one here or this one on the right. Okay, so now at x equals 1, what's our slope? So what's f prime at 1? You'll see that written over here. So just take your equation and plug away. What's -1 squared? 1. 1 times 3 is 3. What's -1 to the 4th power? 1. And -9 over 1 is -9. 3 minus 9. So there's our slope. All right, you know how to do this. From now on, it's just a matter of straight line algebra. Write your equation with m, the one we just found, -6, in place. And then, oh, one more thing. Where did I get, you know, the book, the test said at x equals -1. How did I find this -9 for the y-coordinate? I just plugged -1 into the original equation, clanked it out, and I got -9. So you'll need to do that. Otherwise, you won't be able to, you know, right here, make this substitution for y, -1 for x. And you can solve for b. It's negative 15, and so, ta-da, we have the equation of the tangent line at x equals negative 1 to that graph. All right. Business problem is the 8th problem on this sample test. So, yeah, here's where, remember I told you about this a few minutes ago? You may need that, and sure enough you did, because you see how I gave you the demand equation right here? And I gave you the cost. And this I did not give you over here, this revenue. I had to figure that out by using this guy. Because, why do you need the revenue? Well, because if you look down here, I asked you questions about the profit. Well, do you notice that I never gave you the profit? Not once. So, I should put this down too. We know that you've got to get the profit by subtracting the cost from the revenue. Well, I never gave you the revenue. That's why you have to take this small p equation and using, you know, that formula over there, I need to multiply it by x in order to get the revenue. That's where I got this. So, if you take x times 1.89, you get 1.89x, and if you take x times negative 0.0083x, you get negative 0.0083x squared. Now, I can do this. I can subtract the cost from the revenue. Finally, we have the profit. Well, I gathered the like terms, and here's the simpler version right here. Now, we've already done part A, the profit. That one's done. Can you find the marginal profit? There's that word marginal. That means what? Derivative. So now I have to take the derivative of that equation. Pretty simple power rule. Success. So there's what? That's a pretty minimal 8-question test, but it had, you know, some of these questions like number 6 had, 4 parts to it. Still, that's pretty. It does hit the big things. It should give you. This should all help give you a little bit better idea what might this test be like. So there's the rest of that test that was given to a class like yours, I don't know, some years a while ago, and that should give you a pretty good idea. Now, I pretty much have to depend on questions from you guys. You want to go through any review questions? If so, which ones? Might you still have some questions on problems from any of the assignments? That's where I'd like to go next. Now, if I don't get any, I'll start picking some out, but I'd really much rather pick the ones that you have chosen. So I'm just going to pause here for a few moments. Send me your questions, please. You can use the group chat window. You can send me stuff to my number, 262-510-2046, or just whatever. Email wouldn't be the best, but you could do that too. And if you wait till after the number 8 again. Number 8 on. Oh, you mean on the? Did you mean on the test, Mason? Okay, I scrolled down. There we go. You should be able to see it now. Yeah, somebody just asked me if they could take another look at number 8. So I had scrolled up and got in the way of some people. Okay, I see a question here. I want to see solution to Chapter 2 review questions on 27 and 34. Thank you, Maki. Okay, 27. Mason, I'm assuming you've had enough time to look at that number 8 now. So let's go to the review number 27. Okay, so I don't have the problem here, but if you look in your book, number 27 says, determine the x value at which the function is not differentiable. And then you notice they gave you a graph and they gave you the equation form. But the graph really nails it, doesn't it? What the big issue here is, we've got a graph that's what? It's discontinuous at x equals 0. It's not connected to the other part. So that should have been a what? It should have hit you in the face right away saying, whoa, I can't find a derivative at x equals 0. You can never find a derivative when a curve is discontinuous. So what I wrote on here is, well, you can do a left-hand limit. What's the left-hand limit of that graph as x approaches 0 from the left? Oh, that goes down. Yeah, that's approaching -2 in height. What's the right-hand limit as you approach 0 from the right? Well, now it's approaching +2. And whenever the left-hand limit and the right-hand limit do not agree, then there is no limit at x equals 0, which is a reminder DNE does not exist. That's a reminder that you can't find a derivative when a curve is discontinuous. So that's number 27. Okay, let's take a look at 34. We'll just make a slide for that. Take my keyboard off here so I can do some writing. So this is the review number 34. Get changed to black here. That's on page 167. Okay, the directions: find the equation of the tangent line at the given point, and you can use a graphing utility to check your work. Okay, 34, we have y equals x cubed minus 5 plus 3 over x cubed, and the point is -1, -9. Okay? I would rewrite that as f of x equals x cubed minus 5 plus 3x to the minus 3. Okay? Now, because we're trying to find the tangent line, we need the derivative to find the slope of the tangent line. So, let's find the derivative. Easy derivative, right? Power rule, 3x squared. The derivative of minus 5 is nothing. It's gone. Here we can use the power rule, -9 x to the minus 4, right? You got to reduce the power by 1. All right? So, so that's the general derivative. What's f prime at -1? -1 squared is 1. 1 times 3 is 3. This is -1 to the 4th power, which is 1, and that's on the bottom. -9 over 1 is -9. Actually, this looks a lot like that one we just did on the test. I think it might be the same one. Anyway, we now have our slope. So now we come over to y equals mx plus b, and we insert the slope we just found. And now substitute in the point. So -9 equals -6 times -1 plus b. -9 equals 6 plus b. Subtract 6 from both sides. So then we just come back here, plug in our y-intercept, and we should have finished our problem now. We found the equation of the tangent line. So that's number 34, Maki. Okay, looking for other questions first. Thanks for supplying me with some. Any other requests? At the here we go. Number 8, Maki, on the review, I take it? Must be. All right. I'm assuming that's on the review. So what I'm going to do here is we're going to create a slide. Okay, so this is review number 8. And again, I don't have the graph, so those of you who have, you're really going to have to look at your book because there's a graphic here. It says 2 whitewater rafters have a campsite simultaneously, leave a campsite simultaneously and start downstream. Their distances from the campsite are given by S equals f of t and S equals g of t. So 2 different people, 2 different graphs. One's in gray and one's in black. Okay, so part A says, which rafter is traveling at a greater rate at T1? You notice there's a time there, T1. So in other words, to the best of your ability, which slope appears to be greater at T1? Is it the gray graph or the black graph? They look fairly close to me, but I think the gray graph is a little bit higher. So I would say f of t, whichever rafter that is. Okay, so A, whoever the f guy is higher. Question B, what can you conclude about their rates at T2? Well, do you see now T2 is the black is steeper? So that's the g of t. I'm going to say is greater. So you see, basically, this is general knowledge about rates being derivatives and tangent lines. And the rest of it's eyeballing, pretty much. Part C, what can you conclude about the rates at T3? Well, the black slope is definitely larger at T3, correct? So g of t, again, is greater. D, which rafter finishes the trip first? So the finish line is that red horizontal dashed line. Remember, distance is the vertical coordinate in this graph, right? If you look off to the left, you see how it says distance there? And evidently it looks like T10 is the end of the trip. So the black curve hits the 10 mark at about what, T3? And the gray curve doesn't hit that line until, I don't know, what, T4 or something? We don't have. So obviously the black, the g of t gets there first, doesn't he? Finishes first. Yeah, they never gave us a name for those two people or anything like that, so that's why I'm referring to them by the functions. Hopefully that makes sense, Maki. Looking for another question, other questions on the review or assignments or whatever. Okay, it's calmed down a little bit, so I'm going to just pick out a few more and we'll see how the time goes. So I'm going to go, I'm going to pick one out on the review. Let's do number 15. This is on page 167. The review number 15. And the question says, use the limit definition to find the derivative. So this is one of those questions. Whenever you see those words, use the limit definition. That means you got to do the derivative the long way. So, and then they also gave you a point, and they said use that to find the slope of the tangent line at the given point. So this point off here on the right is what that will be needed for. So I got to remember this is what a derivative is, right? This thing in the black box. So I need to find f of x plus h. So that's simple. Just plug in x plus h wherever there was an x. Okay, that's not that hard. But now I gotta do this f of x plus h minus f of x all over h. So that's the blue part in this section right here. Right in this section right here. Forget about the black for the moment. You got f of x plus h, 1 over x plus h minus 5, minus the original function, 1 over x minus 5, all over h. Well, we got a complex fraction here. Wouldn't it be nice if we could get this top into one fraction? Yeah. So the black is me saying, let's get a least common denominator. And for, for these two quantities here, what's the least common denominator? Well, it'd just be x plus h minus 5 times x minus 5. So the first denominator is missing an x minus 5. So I multiplied top and bottom by that. The second denominator is missing an x plus h minus 5. So I multiplied top and bottom by that. Okay, so where does that put us? Well, first of all, we're going to have a common denominator, right? Here's the common denominator. Those are those two. And then we're going to have these two for the numerators. So you got this x minus 5 multiplied right here, minus this other numerator, x plus h. So in other words, all these get reversed. X minus x, no x, negative 5 plus 5, no 5s, and then you have minus h. So you get this thing. So that's why that numerator lost all its x's because of the way it worked out. And where did this h come from on the bottom? Remember, I've got to divide by h. That's the same as multiplying by 1 over h. So that's how that h has to be on the bottom. And of course, that's always a problem, right? When you're doing a long derivative, you've got to get rid of that h because of this. The limit as h approaches 0, and you can't plug in a 0 for anything in the denominator, or you've got garbage. So, well, the good news is, look, the h's cancel. Don't forget, though, that leaves the negative 1 on the top here. And here's our denominator. And we're done. Now, you don't need to multiply that out. That's our derivative right here. Now, what's the derivative at 6? Oh, by the way, I shouldn't have said that. This isn't the derivative. But when can you now substitute h equals 0? And you can. So this becomes x minus 5. This becomes x minus 5. So you wind up with x minus 5. So here's After you take the limit, here's the derivative. Then going back, they said do this at x equals 6. So what's f prime at 6? 6 minus 5 is 1. 1 squared is 1. Negative 1 over 1 is negative 1. I believe, yeah, that's what they asked you to find. So there's number 15 on the review. Again, you can send questions my way. I'm going to try to get something different going on here, so I am now going to jump up to, how about if we do 37? 37. The directions here are find the equation of the tangent line at the given point. Okay, here's the review, number 37. And so the function's up here, and it's kind of in a weird place, but there's the point. Okay. Our job is to find the equation of the tangent line. Well, the first thing we got to do is find the slope of the tangent line, and we must use the derivative in order to do that. Well, I first rewrote. We could have used the quotient rule, but isn't this the same as this? Let's see. Here, think of it this way. I'm going to just write. I was first thinking this. So if you do x squared over x plus 3 over... In other words, this means divide both parts of the numerator by x. So it's like x squared over x plus 3 over x. Well, what's x squared over x? That's x. And 3 over x we could just write this way. Well, now, not a very hard derivative. Chain rule. The derivative of x is... not chain rule. Excuse me. Power rule. Derivative of x is 1. The derivative of 3x to the negative 1, power rule, negative 1 times 3 is negative 3. X reduced power by 1. Here's our general derivative. What's our derivative at 1? Well, turns out to be, when you plug it in, do the arithmetic, negative 2. The rest of the problem is just, you know, straight line algebra again. Plug in your negative 2 for m. Plug in the whole point, 1, 4, and solve for b. And then you get the equation of your tangent line. Just looking up. Have anybody sending me any questions? I don't believe so. Okay, I'll pick out another example. How about we take number 41, which is to do with business, sales. Number 41. So 41, they give you this equation for sales. Sales equals, and then a big old long polynomial equation where t represents how many years. So do you see their coding is t equals 6 means 1996. So t equals 3 means 1993, etc. Okay? So the question is, yeah, and by the way, what would 2002 be then? That would be 12. So in part A, they say find the average rate of change for the interval from 1998 to 2002. Well, 1998 would be t equals 8. 2002 is t equals 12. And then you just plug them in to get the sales. I'll let you do that, but I mean, just arithmetic. So you go in there, and it's a lot of hacking around because you got to take, like, when t equals 8, you got to take 8 cubed times negative 172.36 plus 8 squared times $4,740.75 minus 35,441 0.6 times 8 plus 98,000. I mean, it's just a lot of arithmetic. So here are the two. Now we've got an ordered pair that represents 1998 sales, and we have an ordered pair that represents 2002 sales. So what's the average rate of change? Hopefully you remember this. Oh, that's just good old slope. So you put it in the slope formula. Y2, that's this guy right here, minus Y1 over 12 minus 8, which I already calculated as 4. Anyway, so what's the average rate of change? 6,976 million, and that's dollars in millions, so it's actually $6,976 million. But so I should write that down. Million. So there's, and then, okay, now what about part B? Let's at least talk about it. Part B says, find the instantaneous rates of change for the model in those 2 years. So now what do I need to do? Average rate of change, just good old slope. Instantaneous rate of change, we've got to find the derivative. Now, even though the numbers are kind of obnoxious, it's just a good old polynomial. So it's really what? Easy derivative, power rule only. Now you've got your general derivative. All right, now find, that would be S prime of t. What's S prime at 8? What's S prime at 12? And you're done. And then C just says, all right, can you tell me what does that mean business-wise? Like, are we better off? Were we better off in 2008 or in 2012? Where did we have a greater rate of change? Which derivative of those two, S prime at 8 or S prime at 12? So just kind of a discussion, practically speaking. Okay, we're kind of toward the end. I leave a couple minutes here for you guys to throw some additional questions in as we're trying to do our best to get ready for the test tomorrow. Questions? Just a little upset that we don't have more people in here live, because especially on review day, it delays all the questioning and answering if you don't do it live. So anyway, I appreciate those of you that are in here. Thank you. Still not seeing any questions, so I am going to stop the broadcast. Thank you very much. I'll see you tomorrow at test time.